In today's lesson, we'll be learning about Pythagorean theorem. In a previous lesson, we learned that there is a relationship among the sides of a right triangle. As an equation, this is expressed as a squared plus b squared equals c squared, where a is the length of a leg, b is the length of another leg, and c is the length of the hypotenuse. The hypotenuse is always the longest side of a right triangle. In our first example, we need to determine the length of this leg. Let's begin by labeling our diagram. That side I'm going to call A since it's a leg, this side I'm going to call B since it's the other leg, and this side I'm going to call C since that is the hypotenuse. We know that A squared plus B squared is going to give us C squared. Let's replace some of these variables with their known values. I do not know what A is, so I'm going to leave it alone. The length of B happens to be 4. Meanwhile, the length of C happens to be 6. Let's simplify this equation using BEDMAS. We know that exponents is one of the first things we need to do. So 4 to the power of 2 is 4 times 4, which is 16. And 6 to the power of 2 is 6 times 6, which is 36. At this point, you'll notice that 16 and 36 are like terms. We can collect like terms by bringing this positive 16 to the other side of the equation. And when I do that, it is no longer positive 16. It actually becomes negative 16. If I simplify the right side of the equation, 36 subtract 16 becomes 20. At this point, you might think the leg has a length of 20 centimeters. But if you look at the diagram, that is impossible. The hypotenuse has to be the longest side, and 20 is obviously bigger than the number 6. So again, take a look at our last line of work. We want to figure out what a is, not a squared. The opposite of squaring something is square rooting it. And what you do to one side of an equation, you must do to the other side of the equation. Therefore, the square root of 20 is approximately 4.5. Therefore, the length of the leg is about 4.5 centimeters. In our second example, we need to determine the length of this leg. I'm going to begin by labeling this diagram. This side I'm going to call A since it's a leg, this side I'm going to call B since it's another leg, and that side I'm going to call C since it is the hypotenuse. You already know that A squared plus B squared is going to be equal to C squared. Next, we're going to replace some of these variables with their known values. The length of A is 7. We don't know what the length of B is, so we're going to leave that alone. And the length of C is 9. Now, we're going to simplify this equation by using BEDMAS, and we need to evaluate these exponents. So 7 to the power of 2 is 7 times 7, which is 49. 9 to the power of 2 is 9 times 9, which is 81. You'll see that there are like terms over here and over here. I'm going to collect like terms by bringing this 49 to the other side of the equation. And when you do so, it is no longer positive, it becomes negative. Let's simplify the right side of this equation. So 81 subtract 49 is 32. At this point, you might think the length of the leg is 32 centimeters. But if you take a look at this diagram, that is impossible. The hypotenuse has to be the longest side, and 32 is clearly much bigger than the number 9. So take a look at our last line of work. We want to know what b is, not b squared. Therefore, the opposite of squaring something is square rooting it. And what you do to one side of an equation, you must do to the other side of the equation. Therefore, the square root of 32 is approximately 5.7. Therefore, the length of the leg is about 5.7 centimeters.